Hi students, welcome to physics classes. Today we'll discuss formation of rainbow, formation of natural rainbow. Now the rainbow is a natural spectrum. Natural spectrum. It is a natural spectrum of sunlight in the form of bow. In the form of bow appear in the sky when sun shines on the raindrop. Sun shine on the raindrop. It is occur in the sky, that is natural spectrum, is known as rainbow. It is in the shape of bow, so we can say rainbow. Now actual its shape is not a bow, it appears like a bow. At the end of this explanation, this session, we'll come to know what is the shape of rainbow. Now here in the formation of rainbow, refraction, dispersion and total internal reflection. Refraction, dispersion, total internal reflection will take place. These three phenomena, these three properties of light, these three phenomena are involved in the formation of rainbow. Now it is formed due to millions of tiny water droplets. Millions of tiny water droplets. Tiny water droplets. But we'll discuss about single individual water drop. Individual water drop. Now when the light rays which are coming from the sun or falls on the top of raindrop, this is the raindrop, on the near the top of its raindrop, when light ray falls, sunlight falls, first refraction takes place. And with the refraction, dispersion also takes place. When the sunlight reaches the top of near the top of raindrop, first refraction takes place. With the refraction, dispersion also takes place. Dispersion means splitting of white light into 7 colors. So it splits into 7 colors. As red deviates least and violet deviates more. Red deviates least, so it will be coming here, and violet deviates more. Red deviates least. Red deviates less, and violet deviates more. Violet is deviating more, so it is coming down, and the red is deviating less, so it will be the top. Now while it reaching to the opposite side of the water drop, this is the first side, so this becomes opposite side of the water droplets. The light rays reflects again back. It reflects back due to total internal reflection. Due to total internal reflection, already here, total internal reflection, it reflects back. In total internal reflection, light ray follows laws of reflection. So it is reflecting like this, it is reflecting like this. While again they'll reaches to the first surface, they will refracts into the air. They again refracts into the air. Okay, now while it is refracting into the air, gap between angle between these two rays increases more when compared to here. Here angle is more. Okay, the angle between incident rays and reflected rays, these emerged rays or this incident rays, the angle between incident rays and emerged rays is anything between 0 degrees to 42 degrees. 0 degrees to 42 degrees. The incoming rays and outgoing rays, incident rays, emerged rays, incoming rays, outgoing rays. The angle between incoming rays and outgoing rays is anything between 0 to 42. But we can see bright rainbow at 42 degrees, maximum angle of 42 degrees. We can see bright rainbow. Each drop is dispersing 7 colors. As we can see here, each drop is dispersing 7 colors. Each drop can disperse 7 colors, but based on the position of observer, he can see any one color from one drop. So to see all the colors, minimum we require 7 drops. So if you see red color from one drop, you can't see remaining 6 colors from the drop, because as the rays are further going, gap between them increases. Already we discussed, gap between them increases as they are going, diverging. So as it is traveling more distance, for the single eye it can't be reached. So it is very important bit. From one drop we can see only one color. So when we see one color in the single drop, remaining 6 colors we can't see. Okay, now here red color we can see at a maximum angle of 42, and violet we can see at 40. Violet at 40 degrees and red is at 42 degrees. Violet 40 degrees, red 42. So in the VIBGYOR, starting violet red, between violet and red remaining 5 colors are there. So total 7 colors we can see from 40 degrees to 42 degrees. 40 degrees to 42 degrees. We can see all colors from 40 degrees to 42 degrees. Now here rainbow is in the shape of 3-dimensional cone. It is in the shape of 3-dimensional cone, and with its tip of the cone ends at the eye. Ends at your eye. Tip of the cone ends at the eye. Okay, this is about formation of rainbow. Here number of times this question is asking, and even they are asking bits from this. If you see one color from one drop, remaining colors can we see or not? We can't see. One drop we can see only one color. And what are the properties of light involved in the formation of rainbow? Refraction, dispersion, total internal reflection. At what angle we can see red color? 42 degrees. What angle we can see violet? 40 degrees. Between what angles we can see rainbow? 40 degrees to 42 degrees. What is the shape of rainbow? Three-dimensional cone. Tip of the cone ends at your eyes. Okay. Thank you for watching. Please subscribe.